Hey there, welcome back. So today we will check the comparable interface. Before we get started with comparable interface, let me quickly show you this particular fragment of code. And this code is taken from our previous videos where we have this print list method, which simply prints the content which is there in the list. And then in here, we have this list of countries and we are printing the output. Now this is cool and we can sort this list as well. Let me show you. First of all, let me create an object of app type. Let me add in a separator for better visibility. And now we will call in collections dot sort method. And now we will print countries, list of countries once again, app dot print list, and we will pass in countries. Now suppose that we don't want to sort the list based on the natural ordering, the alphabetic order in our case. We would require to implement some manual and custom sorting mechanism. Then how we will handle it? Moreover, Java will implement the natural ordering for known types only. If the objects are of custom type, the list is of custom objects, then how we will sort? This is where the comparable interface comes in picture. So let's check how we will implement the sorting mechanism based on custom objects and how the things would be handled. Alright, so let's get rid of all of the code inside our main method and let us also fix the imports. Now this looks good. Now in this particular program, we have nothing but this method print list, which is capable of printing the list, which is good for us. So now we will create a list of custom objects, and for that we would require a class. So let's add in a class. So I will type in class. The name of the class would be, for example, names, and this will implement the comparable interface. And the type for the comparable interface would be definitely custom, which is names. Alright, so now let us add in a field. This would be a private field. Name would be name. And this would be of type string. Let me add in string data type as well. So this is cool. Now moving forward, let us add in a constructor. I will navigate to source and add in the constructor using field. So this is good. Now moving forward, let us get rid of this issue. I will hover upon this, and in here we will add the unimplemented method, which is compare to method. Alright, so now we need to add some logic inside this compare to method. Now understand this. We will implement the comparable interface and this compare to method based on the length of the name. Alright, so let's get started. Now friends, before updating this compare to method, let me show you the syntax of compare to method. So real quick, let me type in string x equals to a maybe, and string y equals to b maybe, right? And in here let me type in x dot compare to maybe y. Now the syntax of compare to method consists of two parts. Now the first part is already available to us, and the second part is received as a parameter, as an argument to the compare to method. So this is important. Now in here, the first part symbolizes the field which is already available to us, which is name in this case. And the second part is nothing but object of names type. And why object of names type? Because in the comparable operator, we have already specified the type, which is names. So this is cool, right? Are you getting it? Name field is already available to us, and the second element which we need to compare is received from outside as a parameter of compare to method. So let me add in the code in here. Let me get rid of this auto generated stub, and in here we will add in a logic which is based on name, which is already available to us, and we will type in name.length equal to, and then we will make use of this o object. Let me rename this and make this as object obj, and we will type in obj dot name, which is the field available inside the object dot length. Alright, and if the length of both of the string is same, then definitely we will return 0. Then we will add in else if statement. Then we will type in name dot length less than obj dot name dot length. Now friends, what's the rule? Basically, you can tweak the logic definitely, but if the first part is less than the second part, then we pass in a negative value if we want to sort based on the ascending order, right? So I will show you the sorting mechanism as well. We will return -1 and let us add in the else part again. Else return 1, which is the positive value. Let me format things a little, and here is our code, which is fantastic, and this should work properly. Alright, let me get rid of this code. Now finally, let us add in a list of names. So in here I will type in list names equals new linked list. As we have multiple operations in here, so we will be choosing linked list names dot add, and we need to add a custom object, right? So we will type in new names, and we will initialize the constructor with Chand maybe, and semicolon. Here we go. Alright, so now let me copy this particular line of code and paste it a couple of times. Alright, the second name could be, for example, add. Third name could be, for example, John. The fourth name could be Mia maybe. Alright, so this looks good, and now we will create an object of app type. So app equals new app, and then we will call in the print list method. So I will type in app dot print list, and we will pass in names. Now as soon as we do this and try to print the list of names, then there would be an issue, and the issue would be names cannot be cast to a string, right? So there is an issue, and the reason is because we are passing a list of names type. So in here we will accept names. Alright, everything looks good. Now if I execute the program, the output is little weird. In here the output is these little weird text, and the reason is pretty simple. We don't have the toString method inside our names class. So let's do that. So in here I will right click, navigate to source, and generate the toString method. Alright, let me click on OK, and I will edit the toString method a little, and I will simply output the name. Now if I execute the program, then the output is perfect, and we are able to see the expected output. Now there is a small little thing. There are a couple of warnings in here, and if we hover upon this warning, it says the list is a raw type. Now what is this raw type? What is the reason why we are getting this issue is something which we will check in our section where we will discuss Java generics, and we will check Java generics in near future. Alright, so now moving forward, let us do one thing. In here we will say collections dot sort, and we will pass in names. So now we are sorting names, and let me add in a separator, and then we will call in app dot print list once again and pass in names. Now what would be the output? So based on the length of the name, the sorting is done, which is perfect, right? For example, if you want to reverse the order of sorting, again that is possible. So currently the order is the ascending order based on the length of the name. Now we will reverse the order. Pretty simple. In place of -1 we will return 1, and in place of 1 we will return -1, right? So we are reversing the order as well in our compare_to method, and now if I execute the program, the order is reversed, right? So pretty cool stuff and pretty simple how we can play with the compare_to method, and definitely you can implement your custom logic for any custom objects. That's your lookout, and you can play with it. So this is all about today's video, and this is how we can make use of comparable interface. Hope you guys enjoyed it.